hang up and try again.
Hello everyone with Math Everywhere YouTube channels with Nizar. I am an IB high school teacher in San Francisco. Here is the derivatives part 4. Now, what are the derivatives of trigonometric functions? I have taught 7 rules and now we will start with rule number 8. What is the derivative of cosine x? The derivative would be negative sine x. Just switch cosine to sine, but don't forget to add this minus. So cosine starts with a C letter, so the derivative will be negative. Just remember that, please. Remember that. Okay? Rule number 9. What is the derivative of sine x? The rule says switch sine to cosine x and keep it positive. You don't need to add minus. So cosine will be negative sine, sine will be cosine. Now rule number 10. What if I have cosine but not x? I have, let's say, ax plus b, which is a linear function. The derivative says, don't forget the minus because cosine starts with a C letter. C becomes minus. And take the derivative of the angle, which is a here. Ax, the derivative is a. So drop this number out and change cosine to sine and leave the angle as it is. Don't change the angle. Angles are holy. Example. What if I have cosine negative 2x minus 1? Just remember, this is a linear function. So the derivative would be minus because the cosine derivative is negative. And I have to drop this linear coefficient outside. So negative 2. And the cosine will be sine. So the answer is positive 2 sine. Don't change the angle. Angles are holy in math. Leave them as they are. Don't change them. Rule number 11. Same thing with sine x. But here I will do sine ax plus b. Drop the number a outside. F prime x will be a cosine ax plus b. Leave the angle as it is again. Example. What if I have sine half x minus 2? This is a linear function. So the derivative would be, take this number a before x, put it outside, half, and change sine to cosine, and leave the angle as it is, half x minus 2. Angles are holy in math, don't change them. Rule number 12. What if I have fx equals cosine, but not x alone and not linear function? Let's say any other function. Let's say jx. I call it cocktail. So cosine, another function. So the derivative would be, take the derivative of the angle and drop it outside. So j prime x times negative sine x. So I would put sine jx. I would put the minus in the beginning here. It's not clear, I know, but if you see this question, it will make sense to you. Fx equals cosine x cubed minus 2x squared plus x minus 10. See, I have a cocktail here. I call it always cocktail. It's called jx. It's another function inside the trigonometric function. How to do the derivative? Quickly, you start with minus. Quickly, because cosine has a C letter. Always C in derivative will be minus. Remember that. So quickly you put the minus because you might forget it. Then now do the derivative of what's inside the cosine. Do the derivative of the angle. 3x squared minus 2 times 2 is 4x. 1x. Here the derivative is 1. We get rid of x. And the negative 10, the derivative is 0. So now you flip cosine to sine. And do copy paste. The angle is holy. Don't change it. So here I have minus j prime sine j x. See, it's easy. You just need to focus a little bit more. Same thing with sine. Rule number 13. What if I have sine function jx? The derivative would be cosine the same function jx, but don't forget to multiply by the derivative of the angle. Put it outside. You can put it before the cosine or after the cosine. It's fine. J prime x. Example. What if I have sine square root of 2x minus 1. See here, there is a radical function inside a trigonometric function, so this is gx. The derivative said, take the derivative of the angle, put it here outside, which is j prime, and flip the sine to cosine. Cosine the same angle, 2x minus 1. Now, what is the derivative of square root? We do fraction. The derivative of what's inside the root is 2 over 2 times the square root of 2x minus 1. So here I can delete 2 with 2, and the answer will be 1 over square root. It's easy. You don't need to panic. It's really easy, but you just need to focus more. Fx equals cosine fraction. What do? 3x over sine 2x. See, you have cosine fraction and cosine rational function. So function inside function, and in the rational function in the denominator you have also trigonometric function. So there are 3 functions inside each other here. You don't need to be afraid or panic, just do it slowly. The rule says whenever I see cosine, I start with minus, because c in math with derivative will be minus, remember that. So I started with minus, and now I will take the derivative of the angle, which is fraction, then now times the cosine will be sine the same angle, so sine this. Don't ever dare delete sine with sine. It doesn't happen, because this is an angle. You cannot delete angle with sine. Please don't do that. It's not multiplication, it's sine this. It's like one word, like San Francisco. It's sine of this, not sine times this, so you can delete. Now, what is the derivative of this rational function? The derivative of up is a 3 times down sine 2x minus. What is the derivative of the denominator? Do you remember the rule that says sine ax plus b? We drop the number a outside, so the derivative of this angle is 2. So 2 cosine 2x times up 3x over the denominator squared, sine 2x. The square, I will put it on sine, not the angle. Angles cannot be squared, remember that. Now we do distributive property. Don't forget the minus here. 3 sine 2x. Now negative 2 cosine 2x times 3x. Don't ever dare multiply 3x by 2x, because this is an angle, it's holy. Don't touch it. Multiply the 3x by 2, so minus 6x cosine 2x over sine squared 2x times sine 3x over sine 2x. Now if you want to distribute this minus, it will change everything. So this will be plus, this will be minus, and you can delete this. That's all. So let's continue with the derivative of trigonometric functions. As I explained that cosine will be negative sine, sine will be cosine. That doesn't mean that tan will be cotan and cotan will be negative tan. Remember that. So what is the derivative of fx equals tan x? The rule says the derivative of tan can be written in 3 ways. Either you say 1 plus tan squared x, or 1 over cosine squared x, or sec squared x. Why? Because sec x equals 1 over cosine x. So one of the 3 will work. Rule number 15. What is the derivative of tan ax plus b? What if you have a linear function inside the tan? So the derivative can be written again in 3 ways. It's up to you. F prime x equals 1 plus tan squared the same angle, ax plus b. But since the angle is a linear function, the derivative of it is a. So don't forget to multiply by a. Where? In the beginning, not before tan squared here. Multiply by a. Or you do 1 over cosine squared the same angle, ax plus b. But since the angle is a linear function, you need to multiply this f prime. You need to multiply it by a, so it's going to be up here, a over. Or multiply by the derivative of the angle outside, and it's going to be sec squared ax plus b. This is the most common one in the IB exams, but all of them will work, and any math teacher in the world will not have the right to deduct any mark of you if you use any of these three. Look at this example. I have fx equals tan negative 2x plus 1. So the angle here is a linear function. The derivative of this angle is negative 2. So don't forget to multiply by negative 2. I would use this one. So f prime x equals negative 2 times sec squared negative 2x plus 1. The angle stays as it is in the derivative always. Another example. Fx equals tan minus x minus 2. So f prime x equals, what is the derivative of the angle? Is negative. So I would use this, let's say negative 1 over cosine negative x squared, cosine squared negative x minus 2. Or you can say negative 1 times 1 plus tan squared, the same angle, negative x minus 2. Or you can say negative 1, because the derivative of the angle is negative 1, times sec squared, the same angle, negative x minus 2. All of these three is right. You can use one of them in the IB exam. What about rule number 15? Fx equals tan, but function, jx. Same thing, the tan has three styles of derivative, 1 plus tan squared, the same angle, or 1 over cosine squared, the same angle, or sec squared, the same angle. But remember, here the angle is a cocktail, which is like a mixture of x and other, operations. So you need to take the derivative of the angle, which is j prime x, and multiply it by the derivative. So here it will be multiplied up, j prime x up, and here it will be multiplied here in the beginning. Example for that, fx equals tan square root of negative 2x squared minus x plus 1. So there is a radical function inside a trigonometric function. Let's use this one, sec squared. So keep some space here. Sec squared, the same angle. So tan will be sec squared, let's say. And now, since the angle is a cocktail, so I need to take the derivative of this. What is the derivative of square root? It's a fraction. The derivative of what's inside is up, so negative 4x minus 1 over 2 times the same question. Negative 2x squared minus x plus 1. That is all. Now rule number 16. What is the derivative of cotan x? Again, it has three rules. Either you do negative cosec squared x, or you do negative 1 over sine squared x, or you do negative 1 plus cotan squared x. Remember, because cotan starts with c, c in derivative will end up with negative. So the answer is negative. Rule number 17. What if I have cotan ax plus b? The angle here is a linear function, so we need to multiply by a. Same thing, we need to multiply by a. So either the derivative will be negative a times 1 plus cotan squared ax plus b, or I can say negative a over sine squared ax plus b. Remember, the angle stays the same. Or I can say negative a times cosec squared ax plus b. Example for that, fx equals cotan negative 2x plus 1. What is the derivative? Let me suppose, or let me use the cosec. The cotan starts with c, c will become negative, so minus cosec squared negative 2x plus 1. But now, what is the derivative of this angle? Is negative 2. So negative 2. So negative times negative is positive 2 cosec squared, the same angle. Rule number 18. What if I have the derivative of cotan but function, which I call it cocktail? Same thing. There are three styles. Cotan starts with c, so the derivative is negative 1 plus cotan squared jx. But don't forget to multiply by the derivative of this angle J prime and put it outside J prime x. Or you can use J prime x over sine squared Jx. Or you do J prime x times cosec squared Jx. I forgot the minus here because cotan starts with C, so the derivative will have minus. So there is minus here. Also here there's minus. Also here there's minus. Don't forget the minus. Be very careful. Example. Fx equals cotan sine 2x minus 1. So there's a trigonometric function inside a trigonometric function. The rule says, since cotan starts with C, so the derivative must have negative. I would use cosec squared, the same angle. Here is the angle. All of this sine 2x minus 1 is an angle inside cotan. So sine 2x minus 1. And now what is the derivative of this angle? See, I will hide the cotan now. What is the derivative of this angle? 2 cosine the same angle inside this angle will stay the same, 2x minus 1. So this is all J prime, and this is cosec squared G, and this is the minus. It is easy. You cannot simplify this more than that. Now rule number 19. What is the derivative of sec x? The derivative of sec x is sec x times tan x. That's the rule. Rule number 20. What is the derivative of sec ax plus b? Just multiply by the derivative of the angle outside. So f prime x will be a times sec ax plus b times tan ax plus b. Same thing. Rule number 21. What if I have sec but function jx? The derivative would be, don't forget to multiply by the derivative of the angle outside, so j prime x, and the sec will be sec tan jx. See, always I put the angle in parentheses, so the teacher who will grade my work will not be confused. So everyone in the world now will know that this is an angle, this is an angle. Example for that, fx is sec 3 tan 2x minus 1. See, here the angle is a trigonometric function. So the rule says, take the derivative of the angle, put it outside, and multiply it by sec and tan. The whole angle. 3 tan 2x minus 1 tan 2x minus 1. Now what is the derivative of this angle? Let me hide the sec. Leave number 3 as it is. What is the derivative of tan? Sec squared, the angle inside, 2x minus 1. Since the angle has ax plus b, so linear function, the derivative of this is 2, so I will drop the number 2 outside. So from the beginning I can write this as 6. That's all. Rule number 22. What is the derivative of cosec x? Since cosec starts with c, any c letter in the derivative will end up with being minus, so negative cosec squared x cotan square, negative cosec x cotan x. There's no squared here. So sec will be sec tan, cosec will be negative cosec cotan. Rule number 23. What if I have cosec ax plus b? Same thing. Take the number a, put it outside, and since cosec starts with c, so the derivative is negative, cosec the angle times cotan the same angle. That's all. Example, what if I have cosec negative 2x plus 1? The derivative would be Since cosec starts with c, I will put minus in the derivative. And right here, cosec, the same angle, cotan, the same angle. But since the angle here is a linear function, it has a number a, the linear coefficient, I will multiply it by it outside, so -2 outside. So here the answer would be +2. That's all. See guys, it's easy. It's the same procedure. If you have a linear function, just put the number a outside. If you have a cocktail like that, take the derivative of it and put it outside. And the same technique. All of them have the same technique. Rule number 24. This is the last one in trigonometry. What if I have cosec but function? Same thing. Take the derivative and put it outside. F prime x equals j prime x times cosec jx times cotan jx. What do you think I forgot? The minus, because cosec starts with minus, with c, so the derivative will have a minus. So minus here. Example, fx equals cosec 2x cubed minus 6x squared plus 3. See, this is a cocktail, I call it. It's a jx. I take the derivative and put it outside and then multiply it by cosec the angle, cotan the angle. Don't forget the minus. So minus, because cosec starts with c, the derivative is negative. Now I would multiply by the derivative of the angle. 6x squared minus 12x plus 3, the derivative is 0. So this is j prime. Now cosec the same angle, the original one, times cotan the same angle. That is all about trigonometry. It's your turn now.